Good morning. I opened my computer at home today to see this image, which I captured. And that's the same highway I showed you on the slope problems. If here is your rise, you got this much plus this much plus this much plus that much run to offset the ratio of the rise to run. Well, let me close that down and we'll get started on where we need to be. Now, as I told you on Tuesday, we'll be going over these, grading these today. Hopefully you finished this sheet yesterday. Hope you enjoyed your day off. As we go over these, if you have any of them incorrect, I suggest that you correct them, and then you'll still get to count full credit on this when you submit your assignment on Friday. Again, on Friday, you'll take pictures or scan these, convert them into a single PDF, like we did last time on the test, and then, or like we did last time, and then you'll send those to me through Blackboard on the assignment link. I'll grade them, put them in the Alex gradebook, and you can see your score there. There are 86 questions on the first page. You'll need to write how many you got correct out of the 86. Okay, so let's get started. Here, we're just finding X and Y intercepts again, and basically, you replace, on the x-intercept, you replace y with the equal 0. This is y, remember? And then for the y-intercept, you replace x with 0. So here we do that. F of x equals 0. X squared equals 4 plus or minus 2. Okay, so you have two x-intercepts here at 2 and -2. For the y-intercept, you replace x with 0, x squared is 0 minus 4, you get -4, so you get the point 0, -4, because on the y-intercept, it has to be on the y-axis, which is x equals 0. So here would be your y-intercept. On your test Monday, it'll give you a problem, something like maybe one of these three, and it'll ask you to identify the x and y intercepts, and you will have to identify which one is the x intercept and which one is the y intercept. Okay, number 15, again, we're going to replace y with 0, okay? So we get 3 minus that. Take the 3 over to the other side, remove the absolute value plus or minus, so we get plus or minus 3 for the x value, 0 for the y. On the y-intercept, we replace x with 0, so here, absolute value is 0, 0, so we get 3 and the point 0, 3. Once again, we replace the y with 0, so we get the 2 on the other side, so we've isolated the x. We square both sides, and we get 4, 0. For the y-intercept, we replace x with 0, square root of 0, 0, so we get simply 2, so 0, 2. Okay, finding the domain and range of functions. In this case, because these go outwards as well as upwards, your domain is negative to positive infinity. This one here, we're going to have infinity this direction. This would imply infinity you could have had a gap on the range, okay? Except right here, the values from -1 to +2 for y are covered right here. So there are no y gaps in the range and in the domain, because at least this point x equals 0 is covered by that inclusive point, then we're infinity to infinity. Now, down here on the ranges, let me scoot that up just a wee bit. Remember, on range, you go from bottom to top. So our lowest value is an included 2 right here, 1, 2, and it goes to infinity. Over here, we have a -10 as our low spot, and there are no gaps in the total set of y values all the way to infinity. By the way, on the exam on Monday, there will be 32 questions, and there will be basically one question on every objective that we've had. Okay, here, because we have an inclusive as well as the exclusive at x equals 1, there are no gaps left to right. Okay. However, this stops at x equals 4. So that's why here, and the 4 is included. Now, for the range, here we have the set of values where y is going to be 1 no matter what. And then we union that with from 2 up to infinity oh, this one stops at 8, so not infinity, but rather 8. Okay, on this one, our domain stops here at -2, continues to the right forever. Our range starts not at -2, but -infinity, okay? And actually, this is wrong, because this is supposed to go from low to high. So the -infinity should be there and the 4 should be there. So it should be -infinity, because this one goes forever, and you go from bottom up to a height of 4 inclusive. So this should be 4 inclusive, that should be -infinity. And these are book-made materials. Okay. Now, basically what we're doing here is they've given you this graph. And what they're saying is, if x is -3, what is y? Because this in its entirety is y. That is the x substitution value. So if x is -3, over here we find x is 1, 2, -3, and we go down until we hit somewhere on the graph, and it's y equals -3. Okay, for problem B, they say they're going to use a substitution value of x equals 0. And what is y? Well, here is 0. Nothing down this way, but y equals 2 right there. On item C, okay, now, what this one is telling you is that y is equal to -1, or it can be rewritten this way. So they're telling you, find where y is -1, and then find x. So that problem is just the opposite of the first two. So where y is -1, okay, would be right here, although it's non-inclusive. It would also be y, negative 1, it says, right here. I better pay attention. So if y is negative 1 right here, then what is x? X is also negative 1. On D, if y is 1, then what is x? Okay, if y is 1, this line, it's not included here, but it is included here at y equals 1. So x should be 2. Determine the x-intercept. In this case, there is no x-intercept. The y-intercept would be the point 0, 2. Okay, which is the next question. And the domain, because this point overlaps and that one goes forever, or infinity to infinity. For the range, we've got infinity to negative 1, union with positive 1 to infinity. That brings us to section 2.4. Graph the equation and identify the x and y intercepts. This equation is in standard form. If they only give us no x, give us x alone and no y. So what kind of a shape is that? If they only give us x, no y, then it's a vertical line. If they only give us y, no x, then it's going to be a horizontal line. In this case, at 2. In this case, divide both of these by 5 and you get x equals negative 2. So over 2 and a vertical line. In the case of this one, you can just replace x with 0 and replace y with 0 to get the 2 intercepts. So if it's the x-intercept, you replace y with 0 and you solve this, and so you get x equals 3 divided by 2. Okay, and here we replace the x with 0, so we get negative 2 equals 6, y equals negative 3, so the point 0, 3, we graph those. Okay, on the slope problems, here you can see the slope formula that we covered earlier. Okay, there won't be specific problems like this on the test, but there will be a test problem where you have to do this as a first step in finding the equation. So we're going to apply this y2 minus y1 over x2 minus x1. They chose to call these 1 and 2. If we had wanted to, we could have done it the other way around. Now, here they've done the arithmetic with that one as 1 and 2. Now I'm going to do the same problem with this one is 2 and this one is 1, just to show you that it doesn't matter. M equals, in this case, we're going to do the y, so 3 minus -8 over -2 minus 1, which is equal to 3 plus 8 over -3. Okay. And this gives me 11 over -3, or simply -11 thirds. Okay, so as you see, it really doesn't matter which order you do them in. What matters is once you have decided which one you're going to name point 1 and point 2, that you stay consistent. I usually like to call this one number 2, this one number 1. Then I can just go boom, 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 writing my numbers here, and I'm less likely to make an error for me. Okay, you can see problem number 5 worked in the same manner. Only difference is now you got some decimals in here, minus a negative, okay? And so you get these. The only difference is that one's using decimals. Okay, here's some stuff about horizontal and vertical lines. On a horizontal line, remember the slope of a horizontal line, that's where the x is missing, so you only have y values, and y is a constant 4. 4 minus 4 is 0, and what this means is it doesn't matter what the x values are, because you'll get 0 in the numerator. The step they skipped right here should have been equals 0 over whatever, okay? I guess that sounds kind of teenagerish. Whatever. Okay, in the case of a vertical line, doesn't really matter what the x values are, because when you subtract the y values, which are always 3, you're going to get a 0 in the denominator, which is undefined. Okay, notice our language here. Positive slope when you've got a positive x, negative when you've got a negative x, 0 slope for horizontal, undefined slope for vertical. Do not use the word no slope. It's no slope is not defined. Okay, here's our y equal mx plus b, which is our basic linear equation, our workhorse, where m is the slope and y-intercept is the b, or the y value of the b point. Okay, so that'll work. So here I'm putting this standard form into y-intercept form. In other words, getting the x on the other side, dividing everything by 3. 6 divided by 3 is 2. Okay, so my slope is 2/3. My y-intercept is -2. Okay, so I start at -2, and I use the slope of 2/3, which means go up 2 over 3, up 2 over 3, up 2 over 3, or down 2 over 3, down 2 over 3. For this one, We're gonna have a negative slope on this one when we get through here, because y equals negative 1/2 x plus 2. Anytime we've got the negative in front of the x, it's gonna go downhill. So our slope then is negative 1/2. Our y-intercept is positive 2, so we go up to positive 2 for the y value. And then we go down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, and so on. Okay, if they give you the point negative 2, 3 and slope of 5, you have to use, there are multiple ways of doing this. I don't care for this way of doing it. The way that I would like for you to do this problem is to use the point slope formula. Y minus y1 equals x minus, equals m times x minus x sub 1. Okay, then we substitute in the information they give you. Y minus 3 equals m5 times x minus negative 2. So y minus 3 equals 5x plus 10. Negative gives you positive. Okay, plus 3 both sides. Y equals 5x plus 13. Okay, if you'll use this manner consistently, anytime you have the slope and you have one or more points, you'll be able to get the answer. Okay, yes, I know there are certain problems that you can come up with where all you have to do is take the y value and put it into this, but that's a very minority, and I guarantee you on my test and on the final, that won't work. You really ought to do it this way. I'll leave that up there for just a moment. What they're doing is the substitution method to get B. Okay, here we're using the point slope formula some more. They tell you that slope is 2 and it passes through this point right here. The y value, the slope, the x value. Now, since this is a minus 4, x minus negative 4 gives us the positive. Okay, here we're just simplifying, we distribute, and we move this 2 over to the other side, and we get y equal to x plus 10. We'll pull up the graph on that in just a moment. Actually, I'll do it right now. Like so. Over here, we substitute in, the slope is negative 2/3, y is 0. Here we have the 5, negative 2/3 plus 10/3 after we distribute, and that won't simplify. So for the graph, 10/3 is 3 1/3, right up here. I don't know what this is the graph of. That's not, that graph is not correct. 1, 2, 3, unless they're letting each one of these be a 2. No, they show that's 7. So 10/3 becomes 1 and, or excuse me, 3 1/3. So up 1, 2, 3 1/3 right there. Okay. Go down 2/3. So down 2/3, down 2 from here. There's 1, there's 2, and right 3, 1, 2, 3 would be here. Down 2 from there, 1, 2, right 1, 2, 3 would be here. Okay, and so the graph would look like that. They had the same slope, but for some reason they elevated this thing, and I'm not really sure why they did that. It was a mistake on their part. Okay, I need to make a note to myself to change that later. Let's see if they graph this one correctly. 10 here, and up 2 over 1, or down 2 over 1, down 2 over 1. Okay, so this one is graphed correctly. By the way, you will have problems like that on my test Monday. Okay, let's look at this one. They give you 2 points and tell you to find the equation of the line and to graph it. You will have a problem like this one on my test. Okay? So first we have to take the 2 points and find the slope. So y2 minus -4, okay, and -2 minus -1 gives us 5 over -1, gives us the slope of -5. So we know that the graph has to go downhill and fairly steeply. Now we pick either one of those 2 points. It doesn't matter which one. They chose point 1, put in the y value, put in the x value, put in the slope. Okay, they distribute the slope, move this 4 over to the other side, and they get y equals -5x minus 9. Okay, down here is 0, -9, and they go over 1 and up 5. And they go over 1 and up 5, and over 1 and up 5. Okay, on this one, they are telling you the slope is undefined. So what they're telling you is that this is a vertical line, and the x value will always be 2. So it's this vertical line. That 0.23 is right here, and yes, it is on that line. Okay, you can see some of the review instruction. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Okay, in these first problems, it just asks you to give the slope of a of a line parallel and perpendicular. Okay, so if you're starting with -3/8, parallel will be the same, perpendicular will be opposite of sign, reciprocal. Okay, on number 6, there is a hidden over 1 here. So same 20, perpendicular, opposite sign, reciprocal. If the slope is 0, that means it's a horizontal line. Same is going to be 0. Perpendicular in this case would be a vertical line, which is undefined slope. Because if you put 0, 1 over 0, it would be a negative value. I mean, a imaginary value, an undefined value. Okay, here we give you the equation of a line that passes through this point and is parallel to this equation. In other words, we start with this equation, y equals 3x, y minus 3x equals 4. So the first thing we have to do is put this in slope-intercept form. Y equals 3x plus 4. Okay. What happened was this -3x, when moved over, became positive 3x. Now, our slope is going to be 3. Okay. So we take this slope and we take this point. So they want the equation of the line that goes through this point at that slope. It may or may not be the same line. So we put in the y value, we put in the x value, we put in the slope. We distribute, take the 2 over, and we get y equals 3x plus 5. And we could graph that if we needed to. On the second one, they give us this one in standard form. So the first thing we want to do is put it in intercept form right here. The slope is because this says it's got to be perpendicular, we take this -5/2 and we're going to use our slope on our perpendicular line of positive 2/5, the opposite sign, reciprocal. So here's our slope, and here's our point. We use the point slope formula, substituting the 8 and the 6 and the 2/5. Okay, we distribute, take the 8 over to the other side. We're going to have to play the common denominator game here and make this 40/5. So 40/5 minus 12/5 is 28/5. And then 2/5 x. So this is the equation of the line here. In other words, here, I would make this 40/5. All right. Okay, this is a modeling problem. There will not be any of these modeling problems on my test Monday. But I want to go over it again with one example. Hardware store charges $28 to rent a carpet cleaning machine for 24 hours, $10.98 for each medium-sized bottle of shampoo. Okay. Now, in this case, it says write a linear function so that S, the cost of renting the machine for so many days, along with 2 bottles of Rudd shampoo. So they have $28 a day plus 2 bottles at $10.98. Okay, gives you this, simplifies to that. Okay, and so that would be your linear equation that they want you to model. Okay, evaluate and interpret in the meaning of the context here. Well, what this means is that the total cost for 2 days and 2 bottles would be $77.98 because you would replace this with a 2. So it costs $77.96 to rent the machine for 2 days with 2 bottles of shampoo. In your final answer, if you were to forget that $sign, it would cost you 1 point. If it's a word problem, always label. If you're wondering what these gaps are, these are where problems were that we don't have in our criteria. Okay, you guys have seen this before several times. Okay, I've shown it to you at least 4 times, maybe 5 times in terms of the graph types. You've got linear equations where y, there is no x, you've got a horizontal line. Okay, here y equals x is the identity line over 1 up 1. Absolute value is your classical 45-degree V. X squared is your parabola with vertex at 0, 0. X cubed takes this shape, passing through 0, 0 right there. Okay, square root of x is half of this one at a 90-degree angle. And the reason we don't have the bottom half of this is because we can't have a negative square root. Cube root of x is this one at a 90-degree angle. The positive and negative doesn't bother us on this one, on cube root, because with cube root you can have negative x values. The reciprocal function, 1 over x. Okay, if you remember right, y equals x is that. 1 over x is going to look like this. Okay? 1, 1, negative 1, negative 1. This approaches x equals 0. This approaches x equals 0, but it never quite touches. That line where it never touches, I told you, is called an asymptote, and that'll become more important later. Okay, apply vertical and horizontal shifts. Okay, what happens for a vertical shift? We add to the x value or subtract from the x value if we want to go down. So this moves it up, that moves it down. Okay. Horizontal shift is where the value is included with the x in a parentheses, radical, or absolute value symbol. When it's included inside with the x, then it's going to shift it left or right opposite of sign. Okay, so a negative number would shift it to the right that many places. A positive value would shift it to the left that many places. Here's an example of this. Now, very frankly, I don't care whether you do these point plots or not. Okay? Here are the points for this one, here are the points for that one. Because if you can graph the basic y equals square root of x, and then just shift it up to, and show me both of these lines and label them, okay? That's g of x equals square root of x plus 2, and this is just f of x equals square root of x. Label them like that without showing that. If you can do this from what we've done in class, I will be perfectly happy with this without you plotting all those points, and in some cases on your calculator. Okay. Likewise over here, this time the 2 is under the radical, so that means it's going to shift it left or right. Once again, here's f of x equals square root of x. And then this one is, what do they call it? They call that one f of x. I'm going to call it h of x equals square root, I'm running out of blackboard space, square root of x minus x plus 2. Label them something like that, okay? Or you can rename this one if you want to. Call it h of x. But if you can graph them this way by transformations only, I'm not going to require you to fill in all those point values that you could compute. That's why we've been doing this, is to say, I have a favorite phrase. Work smarter, not harder, for Carter. And what I was telling you then is working smarter. Okay, now let's look at these two. H of x equals that. Okay. F of x, this is f of x here. This is f of x here. Once again, parabola with the vertex at 0, 0. So for h of x, we know that it's got to be a basic parabola because there's nothing in front of or with the x. And we know it's got to go down too. So it would be this graph. In this case also, here's your basic. And this time it's contained inside with it. So we shift it opposite of sign 2 places. And so here it goes. Now, how do you know the shape of this one? Well, if you look at this one here, we got 0, 0, 1, 1, negative 1, negative 1. We just add 2 to each one of these. 2, 0, 2, 1, and 1, 1. Okay, this one was moved over twice. This one was moved over twice. Likewise here, moved over twice, moved over twice. Number 3. This time we have 2 transformations. First, we have a left-right shift, and then we have an up-down shift. Okay, so the horizontal shift, we're going to go 1 opposite of sign, so 1 space to the left, and then we're going to go down 4. Okay, so here's our graph of f of x, and we go 1 to the left, and down 1, 2, 3, 4. Okay, notice this points up 1 over 1, left 1 over up 1. Just like here, it was right 1 up 1, left 1 up 1. Same shape, just transferred over and down. On my test and on the final, you will have problems similar to this, where you are given an equation and you have to tell what transformations are happening. You would say it has a horizontal shift of 1 left, a vertical shift of 4 down. Okay, another equation, y equals absolute value x minus 2 plus 3. We know the absolute value equation has its vertex at the origin, up at a 45, up 1 over 1, up 1 over 1 in terms of the slope. So this -2 is going to shift it 2 places to the right, opposite of sign. And then the 3 will shift it up 3. So from here we go over 1, 2, and up 3. And then basically draw the same graph shifted up with that new vertex. Okay, stretching. If you've got an equation, y equal f of x, and you pick some positive number, a is bigger than 1, okay? If you take a times the y value, remember this is y, f of x is y. If we take a times the y value, okay, then that's going to make it steeper. Okay. Now, if you've got a fraction, then this is going to make it flatter. Example. This compared to this, or this compared to that, and the vertex is supposed to be right there. Okay, so that's what we're talking about. Now that's for vertical. For horizontal, here we've got the a times the x. Okay, now let's just look at this. These two statements are the opposite of each other. This is saying if you make y bigger, you're going to stretch this. And this is saying if you make x bigger, you're going to flatten it. Here, if you're going to make x smaller, a fraction, then you're going to stretch it horizontally or flatten it. If you make that one, then you're going to steepen it. In other words, these are reciprocal type of actions. In other words, the horizontal strength stretch is just the kind of the reciprocal of vertical strength stretches. If you have continuous figures. If you have broken figures, then it takes on a little more meaning. Okay, graph these. Okay, here's the equation. What are we going to have here? Okay, y equals this. X squared is this black line here. For 1/4 of that, it's going to stretch it horizontally or shrink it vertically. Okay. This one, where we're taking 4 times x, this red curve, we are stretching it vertically or shrinking it horizontally. You see how those are just kind of reciprocal ideas. Whether you're talking about, if I ask you what happened here on this red one horizontally, it shrunk in compared to this one. If I ask you on this red graph, what happened to it vertically, it stretched compared to the original. On the blue graph, if I ask you what happened to it horizontally compared to this one, it stretched horizontally. And if I ask you what happened vertically on this blue line compared to the black one, then it shrunk vertically. That's why I prefer the phrases flatten or steepen. That way you don't have to worry about horizontal or vertical, because those two terms of mine work kind of universally. Okay, here's a couple more examples. Again, this is on the inside. Okay, what's going to happen here? Well, because that is on the inside there, then it's going to make it taller. Okay, and it's a multiple, not an add-on. This one, we're basically taking x times 1/5, which makes it 1/5 as tall as the original. This one is 5 times taller than the original. Okay, here we have some piecemeal parts. Let me scoot that down just a little bit. Actually, it's time to start. Stop. This is where I'll have to start tomorrow. So we'll just have to go with that. Tomorrow we'll finish grading this set of handouts. Then you can submit them to me by not later than 10 o'clock. Remember to put the total number you got correct. As I'm sure you've seen so far, it's easier if you got the work there before, so you only have to make minor changes if you find some small error. So finish these up before class tomorrow if you haven't already, and we'll finish grading them tomorrow and maybe spend a little bit of extra time reviewing for the exam one. On Monday, it is in person, so you need to be here. I want to reiterate, you can be here by 10 after 11 if you want to start early. If you want to start late, then our regular time, that's fine, but you can only have until 12:20 no matter what, because another class comes in here. If there are no questions, then we're done for the day. Have a great day.